Hello everyone. Today we'll talk about the inventory of discrete distributions. So we've already talked about the uniform, discrete uniform, the Poisson distribution, but there's a bunch of other ones. And this section is not unlike the other ones where there's a lot of theory. There's no new theory in this one. It's just an inventory. Think of it as a reference manual. Anytime you encounter one of these distributions, you can find the appropriate page. Okay, so this is the discrete uniform, the Bernoulli, so just a binary trial, true or false, heads or tails. We previously called it a coin flip, but now you know the real name is Bernoulli. Then for the remaining ones, you need to know some combinatorics. So in particular, the n choose k formula. And factorial you've seen before, I'm sure. This is rather new. And trust me, you have to learn this notation. It's really powerful. Without this notation, you would have to explain, like it comes up in several different places in math, and it's worth knowing. This is called the binomial coefficient, because this is a binomial. A binomial is a polynomial with two terms, or an expression with two terms. So a plus b is a binomial. And then if you do a plus b to the power n, and you expand that, you see the coefficients in the expansion correspond to n choose 1, n choose 2, n choose 3, and so on. So that's why the name comes binomial. That's where the name comes from. Similarly, there's a binomial distribution with p and 1 minus p, depending on, so it looks like this. The Poisson distribution we saw with the hardest examples, but here are some more calculations, some of its properties. The mean and the variance. Geometric distribution is x minus 1 failures and then 1 success. So it's another common one. And the negative binomial, though this one it's not really that important, but it's so easy to learn after you've seen this one that it's included as a bonus. Okay, that's it. I mean, it's a reference manual. It's not no new theory, but the exercises will ask you to use the computer models to play with all of these distributions. In each case, there's different parameters, so you get to know the parameters. And this is a reminder of the methods you have on random variable objects. A little worked example. So there's a cool function. So plotting the probability mass function requires 3 steps. Evaluating, choosing the range of inputs, evaluating the PMF, and then plotting. And the function plot PMF does these 3 steps for you. So produces exactly the same plot. There's also some explanation about the binomial coefficient. Optional reading, but it's so common and it comes up so many places that, might as well read it. So then there's some more math about the geometric series and the exponential power series. I'm showing these just so that I can give you good exercises. Otherwise, the exercises, if you don't know these math formulas, it will be we're very limited in what I can ask you, but by showing you these formulas, now you're liable for being asked more complicated math equations. Sorry, that's life. And that's a cool picture, the relations between the different distributions. Many of the distributions are special cases or sums, and you can read all about that in the discussion section. So that's it. It's a pretty simple. Don't skip it, but don't read it deeply. You know, this is a reference manual. Look at the pictures for sure. Like you need to look at the graphs of each distribution. And also the notebook. Here you go. This is the uniform, random uniform. Here's the Bernoulli. Try changing the parameters. Let's say we change 0.4. So you get a different distribution. So that's the notebook 23 underscore inventory distributions discrete dist. Okay, check this out. But otherwise, it's a chill week. Get ready for the calculus tutorials. Okay, so next section, we start in continuous random variables. And this is part of the extra reading. You have to read all about integrals. Okay, so you have a chill week before next week, which is going to be more intense. All right, see you all next week.